rate of change. We have this thing called slope. And slope equals rate of change. And if you remember the old slope formula, it's y2 minus y1 over x2 minus x1. We're going to call that delta y, the change in y, over the change in x. Okay, this is the Greek symbol for delta, that triangle. Like in Louisiana, it's called the delta because it's always changing. Okay, and you'll see that quite often. So it's the dependent variable over the independent variable. Example, miles over hours. And that little symbol, that divide symbol, is usually the word per. Average rate of change on an interval from A to B is represented by f of B minus f of A. So this gives you y1, this gives you y2, this is x1, this is x2. Sometimes this is, you'll see this reference in calculus as called the difference quotient. Because you're subtracting and dividing, okay? But it's just the old slope formula. All right, it says, find the average rate of change of this function, the natural log of 3x, over the interval from 1 to 4. Well, how would I do that? I'm going to put in f of 4, because they tell me what f is, so I don't have to write it, minus f of 1 over 4 minus 1. And I got the natural log of 12, because 3 times 4, minus the natural log of 3, because of 3 times 1, divided by 3, and I got approximately 0.462. And I'll show you how I did that. First, I went to my calculator. Maybe I've shown this before. And a y1, I put in the ln of 3x.
I just put that in the calculator, normal stuff.
Pardon?
I just put in parentheses ln of 2 minus ln of 3, then all that divided by 3.
You mean the ln of 12?
Yeah, that.
Yeah, okay. And what you can do, okay? And then, but I'm just letting you know that you can then try, on your calculating part, you can say y1, put in 4, minus y1, put in 1. You'll get an answer, and you can take your answer and divide it by 3. I think I showed you that before, didn't I?
So you put it in a table?
I didn't put it in a table, I did this. I'll show you. I'll do it on a Casio, it's the same thing. So, if I go to my menu, and I go to my graph, and
you did it on a graph.
And I said, all right, I'm going to take the natural log, parentheses, 3x. So that's always into y1 now. And so I go to my menu, come over here, and you get, and TI people, you have a button that says vars also. And if you press vars, I go to graph on a Casio and I just type in y1 and I put in 4 minus Y1, put in 1, press enter, divide, there's my answer, by 3.
So you go to vars, then what?
I went to vars, graph,
Okay,
okay, and then you should see your Y on the left side.
so YT. Do I press YT?
Did you get a Y like this?
I didn't grab anything. Should I press YT though?
No. You don't want to press YT.
Oh, so
That's something else. I don't want to spend a lot of time on this, so I'll show it to you again.
okay.
All right, so it says here, average rate from a table. So this is my hours. This is my miles. And it says, find the average rate of change over the interval from 2 to 30. So I'm going to put in f of 30 minus f of 2 divided by 30 minus 2. And if I look at f of 30, right here it is, here's my 30, this is my y value. What some people do by mistake is they put 30 up here. This is my y value that's computed by this function. So it's going to be 7 minus, over here's 2, and I have a negative 2, divided by 30 minus 2, which is 28, and I get 9 over 28 miles per hour.
You give MPH.
Yeah. Miles is on top, hours are on the bottom.
Okay, so I'm pretty sure this all makes sense currently. I'm waiting for it to not make sense.
All right. The following quotients express the average rate of change over an interval. All right. So I'm going to start with this. F of B minus F of A over B minus A. Let's say I have a graph that looks like this. Here's my y-axis, here's my x-axis,
Okay, this looks like that.
and I got a parabola. And right here, I have a point, A, comma, F of A. And I move over a certain distance. That distance is H. And I go up here. And so my X value is A plus H. Is that making sense to everybody? So if this was a -1 and I went over and H was 3, I'd have a -1 plus 3, I'd be at 2, wouldn't I?
Yep.
Okay? And I'm going to put that A plus H into F to get my Y value. And then I'm going to compute that slope. So this average rate is also the slope of the secant line. This B right here is right here.
So A plus H equals B.
A plus H equals B, exactly.
Yeah.
Does that make sense to everybody?
In other words, A plus H.
Alrighty.
We just put in B for anything that's A plus
So
H.
now let's see if I can get this to work. Give me a few seconds. Because this is a big idea.
It's all black.
Yep, should be. Okay, see that? Move a little bit over. Okay, there's that parabola, right? See if I can make it a little bit. Is it easier to see now? So here's this point. I went over H, correct? And here's the point, x plus H, f of x plus H, correct?
Mm-hmm.
And that gives you that particular slope. Now what I'm going to do, let's see if I can, yeah, okay, properties. I want to show a value. So my H is 1.9. Okay? So whatever this X value is, this is A, B is whatever X is plus 1.9, correct? And what I'm going to do is I'm going to decrease H. H is getting smaller. And my secant line is changing, right? It's
I do not
changing
see
slope.
anything happening.
What?
I don't see anything happening.
Well, I want to eventually. This right here is an average rate, correct? It's the slope of a secant line. What I'm going to do is I want to be able to figure out instantaneous rate or the slope of a tangent line. And notice as H keeps getting smaller,
Your screen.
So yeah, we have no clue what's going on, but I think what you're going is H is going to be 0.001 or something along the lines of that.
Really? You decided to quit on you. That means I have to unplug it, restart it. Alright, I'm gonna draw the picture.
Am I hearing that we're going to turn H into like a very, very small number?
Yeah.
I knew it.
I'm not gonna mess around with it. Yes, you guys have no idea what I was talking about. So there's my picture, correct? And I have a secant line that's right there. And so this right here is H. But if I make H smaller, my secant line starts to approach my tangent line. Does that make sense? Okay. So,
So we're trying to turn our secant line into a tangent line?
pardon?
Are we trying to turn the secant into a tangent?
Yes, exactly like that. Okay.
I'm on a roll today.
So, this is how we compute instantaneous rate of change. The following limits express instantaneous rate of change of a function at a point x equals a. And if you take a look, when I have this right here, a plus h minus a, right? Here's b minus a. And then all of a sudden, I get a plus h minus a. The a's will be canceled out, I'm left with h. Would everybody agree with that?
Yep.
Okay, so like when you guys wrote it down on the test, 5 minus 4.99, that 0.01 is h.
Yeah, that makes
Would everybody
sense.
agree with that?
Mm-hmm.
Okay, so if I make this move to 0 and take the limit, that limit is the instantaneous rate or the slope of the tangent line. I'll say it again. It is the instantaneous rate or the slope of the tangent line. Okay? This one is the same type of thing. So what's happening here I have a point right here that is a comma f of a. And over here I have a point that's x comma f of x. And when I move that point in that direction, x is starting to move towards a. The distance between them gets smaller. Does that make sense? It's the same idea. So as x is over here, as it moves in this direction, f of x is moving towards f of a, isn't it? Right? So there are two different ways to look at that. So this is also the slope, I guess I'm being redundant, of the tangent line. Instantaneous rate, slope of the tangent line. Exactly the same. Slope of the tangent line, instantaneous rate. Does that make sense? Next page. So we're going to figure out the slope of the tangent line, or the instantaneous rate, if f of x is this function, at the value x equals a negative 1. So it's going to look like this. The first thing I did over here is I figured out what f of a negative 1 is. Because I'm going to need to know that. A is equal to a negative 1. So this is really a right here. And when I put a negative 1 in here, it says take a negative 1 minus a negative 1 squared, correct? And so f of a negative 1 is a negative 2. Everybody okay with that? So over here I got the limit as h goes to 0. I've got this. H is on the bottom. Right here I'm going to have minus a negative 2. Okay? Well, the next thing I got to put in is I got to put in into f a negative 1 plus h. Where'd the negative 1 come from? A is a negative 1.
I have a question. Shouldn't it be 0, h be approaching 0 from the right?
The function is continuous and smooth, and we're going to talk more about that.
It's usually because if we change h to 0, it does not exist.
I'm going to show you what's going to happen, okay?
Okay.
Okay. And so what does that mean? That means if I follow this function, I'm going to have, this is equal to x, which is a minus 1 plus h, minus a minus 1 plus h squared. So here's x minus x squared. Here's x minus x squared. So I'm going to have a minus 1 plus h minus, what do I get when I square this? 1 minus 2h plus h squared. I did that in my head. Right? You just double the inner and the outer. Okay, I see people nod, like, you know what I'm talking about. Plus h, I'm going to distribute, minus 1 plus 2h minus h squared. And that gives me a minus h squared plus 3h minus 2. Would you agree?
Yep.
Okay? Everybody okay on that? Now, so what's going to go into here is this. So I'm going to have a minus h squared plus 3h minus 2. And that was this. And this is this. So, different color pen. Limit as h goes to 0. H is here on the bottom. Minus h squared plus 3h minus 2. What's a minus negative 2? Well, I think that's a plus 2, isn't it?
Mm-hmm.
Bam, gone. Okay? Limit as h goes to 0. And Matthew was right. This h on the bottom is problematic. But I can factor out an h here. And I get a minus h plus 3 over h. That 0 is a whole, correct? I'm going to remove it. Bam! It's gone. So I have the limit as h goes to 0 of a negative h plus 3. What's my answer?
3.
3. 3 is the instantaneous rate. 3 is the slope of the tangent line when x is 1 on this parabola.
You mean negative 1?
Yeah, when x is a negative 1. Did I say 1?
Yeah.
Negative 1. Okay. All right, let's look at this one. Let's look at it this way. So now my limit is as x approaches a negative 1 of f of x, which is x minus x squared, minus a negative 1 was
Plus 1.
Was a negative 2, wasn't it? I believe that we figured that earlier, right?
Do something up on my pencil.
Over x minus a negative 1. I'm going to rewrite that a little bit. And I get negative x squared plus x plus 2 over x plus 1. So, can I factor this? Well, I can come up here and I can factor out a negative out of x squared minus x minus 2. Isn't that, aren't these the same right here?
Yeah, let me see.
And so I got a negative x minus 2, x plus 1. Would you agree with that?
Yep.
So now I can write this limit as x goes to a negative 1 of a negative parentheses x minus 2 parentheses x plus 1 parentheses over x plus 1. I got a whole at x minus 1, right? X equals a negative 1. That's what I meant to say. Dot, dot, dot. So now, I'm going to take the limit as x approaches negative 1 of negative parentheses x minus 2. Well, what is that? A negative 1 minus 2. What does that equal?
3.
3. Both ways give me the slope of a tangent line. Both ways give me the instantaneous rate.
Which one can they both be used at all times?
Yes.
Now it's just figuring out which one is more
Okay.
easier for me to do.
Okay, now, notice this is in a particular form. You're saying, oh my gosh, I've got to do that? No, we're going to read the directions. So I'm taking number theory. I'm taking a test. I decide not to read the directions. And I knew the question was, prove that the square root of 2 is an irrational number. My favorite proof. And so I started proving it. I only had to do, there's 2 parts. If I read the instructions, it would have said, only do the first part. But it took me all hour to do that entire proof. I missed the other 9 questions. Because I didn't read the directions. Read the directions. Identify the function we are working with. What function are we working with on that problem?
A polynomial? No, not a polynomial.
What's the function we're working with?
Logarithmic.
5 ln. And with what? Remember, it's got to be in terms of x, correct?
Oh, yeah.
Is there parentheses?
Yes.
2 over,
X.
I'm going to say x. Now, up here, x was a negative 1, correct? Oh, I gotta make this smaller. Up here, x was a negative 1, right? And I plugged a negative 1 into there. What am I plugging in here? What's my a? What's x gonna be to make it a half here and to make it 4 plus h here?
4.
4, isn't it? Wouldn't you agree it's 4? Because 2 over 4 is a half. And then I'm making h really small. Here's my 2 over 4, plus h is really going to be a small number. So the answer here is 4. This is in the limit as h goes to 0 of f of a plus h minus f of a all over h. So if you take a look, both of these have 2 on top. How did I get a 1 on top and a 2 on the bottom? Well, when I plug 4 into here, I get that. So a has got to be 4. And then I have this 4 plus h. Sure enough, I have 4 plus h. Everybody follow that?
I think so.
Let's look at the next one. What's my function?
So, definitely have a sign.
Sine.
I think of
And this is in the form of the limit as x approaches a of f of x minus f of a over x minus a. So what does a have to be?
1.
No.
Pi over 2.
Pi over 2. What is this 1?
The sine of pi over 2.
Sine of pi over 2. Is it 1? By God, it is! It's not 0, right? Here's f of a, here's a. A is pi over 2, the sine of pi over 2. It's in this form. Because there's going to be questions that say, hey, this is the direct definition of instantaneous rate. What's the function? What's a? And you can say, okay, I got this. What matches up? Here's x, here's minus, here's minus. Here's a number, there's my number. Why is this number on top different? Because it's a y value that the function gives you.
Oh, so that
Is that making sense?
makes a lot more sense now.
Okay, and we're going to be practicing those. So let me hand you this.